full of seas and oceans, which is basically salt water. Okay, so this water is like very salty, and it can this water is too salty, and that it cannot be used even for watering the plants. For irrigation also we cannot use because it's that salty. So only a tiny fraction, which is 3% of the Earth's surface, is available to be used as fresh water. Okay, so out of this 3%, so around 2.9% of the water from this, which is remaining, is 0.1 only. So 2.9% of it is locked water. Locked water in the sense they are all in the frozen forms. They are in the mountains, glaciers, or they are buried deep under. So it's very difficult to extract from them. They're very costly to extract. You must have seen these Himalayan water and all. You can see Himalayan water bottles. They're all very costly because it's very difficult to extract water. Okay, so there are water bottles which the water itself is like very costly. Okay, this is Fiji water bottle which you get at airports and everything. They're all, I can see, it's like 100 rupees one water bottle. So it's like, it's written over there, it's directly from the fresh glaciers of Himalayas and all, but we don't know if that is true. So in these regions, water extraction is very difficult. Okay, just 1 minute. Okay, so this locked water, in the sense they are in the mountains and buried water and all. That's basically underground water and all. Okay, in those regions, in the Antarctic and Arctic regions. Okay, so they are very so very difficult, and they are costly. Okay, so now you can see only 0.003% of water is available in the form of 730 Tadaxol. So 7 o'clock. Groundwater and river, lake, stream, soil moisture, and everything. Okay, so you can see very small amount of water. That is why water conservation is very important. Okay, so I'll just show you like a graph. I'll draw and show you like a graph. Okay, so this is the amount of water. I use my use my. So I'm just drawing this so it will be easy for you to know. This is all water that is there in the earth. Okay, so in this all water, only this much is fresh water. Okay, so this is just a simple representation I've given over here. So among that, this small part of fresh water, I'm just showing this as a whole circle. Okay, just imagine this is the whole of fresh water. Okay, so among this fresh water, around 0.7% of the fresh water is in the form of lakes. Okay, and this much, around 0.005. This 0.7 and 0.005 is from the 0.003. Okay, so it's even more smaller, I'm showing you. Percent is in the form of soil moisture. And from that, you will have a few in the biotic regions. That is basically in the rainforest and everything. So in the biotic regions, you have around 0.001%. And finally, in rivers and all, in the form of rivers, it is around, sorry, rivers is another very small portion only. This is only river. Okay, so rivers is another 0.001. This is biota. It's basically in the rainforest and all. And then you have the water vapor that is there in the atmosphere. So this is another 0.001. Okay, so this is the basic distribution of the fresh water that is found in the atmosphere. Okay, is this clear or is it confusing? Is it clear?
Yes, miss.
Okay, so since there's a lot of graph and everything, just make note of this. Tell me once you're done. Okay, and 1 minute, I just have a call. I'll just speak and come back. Are you all done noting or you're still writing?
I'm done.
Who and all is done?
I'm 3 days, I'm done.
Who else?
Ma'am, this is at least I'm done. Ma'am, one.
Okay. Others is still writing. Only Sritej and Adrit has completed. Okay, make it quick, guys.
Teacher, I joined just now, teacher.
Yeah, I just saw. Why are you late to class?
Teacher, actually, I'm not feeling well.
Okay, okay, fine.
Teacher, water topic is only going on in class, no?
Yeah.
Okay. Ma'am, this is what I am done.
Okay.
Ma'am, this is deviation done.
Okay.
Ma'am, I'm done, Aishwarya.
Okay. Who else is still writing? Anybody else who's still writing? Okay. Just a moment. Okay. So we've seen the distribution of water, that is according to the percentage. Okay, this is very important. Please study this. I will definitely ask questions from this for the weekly test. Okay. So now we have seen the distribution. We're going to see the uses. How many percentage is used for what? Okay. So besides being an essential part of life, water has been used for many other purposes other than just drinking. So for other than just drinking, for what else is water being used?
Ma'am, for bathing, for washing, and for cooking.
Cooking, okay.
Washing, cooking.
Washing,
Agriculture.
agriculture. That's it. Only agriculture and our household needs. That's it.
Construction of buildings.
Construction of buildings. So what does that come under? They all come under industrial needs. Okay. So besides essential part of life, around 70% of the total water that is being available. So from 70% that is being um, available for basically 70% out of the 0.003%. Okay. So that's 70. I'll just again draw the chart and I will show you. That will be more easier for you. So 70% of it is used for agriculture. So most of it goes for agriculture. And the amount of water that we use every day is basically all the domestic needs. That is 8%. And 22, please mute yourself. 22% is for industrial needs. Okay, please mute yourself, whoever mic it is, please. Okay, so this is the distribution of water according to the use. So agriculture, the use of water for agriculture in our country, you know that in India, most of the in the rural areas, their life is completely dependent on agriculture, the farmers. So they completely rely on water, the rainwater, the water for watering the crops, because that is what gives them a living. Okay, so farmers rely on water to sustain their agricultural crops for wheat, paddy, and all. So many times rainfall, you know that it is not sufficient for them to water these crops. And farmers, they have to use artificial watering systems, like for irrigation systems and all. So here industrial needs, so I'll just write it down. Sometimes they depend on rain or artificial. What is the meaning of irrigation? What means irrigation? Shritesh? Shritesh, am I audible to you?
Ma'am, 1 minute.
Yeah. Anybody else who knows what irrigation is?
Ma'am, agriculture. Ma'am, can I say now?
Yeah.
Ma'am, it's like the supply of water to land.
Yeah, basically watering. Watering of the crops is only irrigation. Okay. So they completely depend on water for the growth of paddy, wheat, etc. Okay. So whereas coming to the industrial needs, so you know that industrial factories, they use a large amount, gallons and gallons of water they use as a raw material for so many purposes, such as making, cleaning agents and all, for cleaning purpose, for heating purpose, for making glass and many industrial products and everything. So heating purpose, for cooling purpose, for generating electricity. So for all this, they use water. Electricity basically using water turbines. Okay, so the amount of water required depends on the size of the factory. Okay, depending on that, the water they will use. So personal, whereas personal and domestic needs. So here, right, depends. Okay, coming to the domestic and personal needs, we need water. For what all we use? We use it for drinking, bathing, cleaning. Okay, so for many of these purposes we use. So water that is suitable for drinking is called as potable water. Okay, so we also need water for bathing, washing our clothes, our dishes, cleaning our house, to water our plants. So apart from these uses, water is also used for transportation and recreation. So this is regulated by the climate, basically the ponds, lakes, for a beautiful view and everything. Okay, so that is, recreation is basically for relaxation when we go to a hill station or any place where there is a lake view or a pond view. Okay, so for that, which is restored by the climate change and everything. So there are different states of matter of water, you know that. So water exists in the three states, which can be in the liquid. Liquid is in the form of rain, river, sea, and all. Solid is ice, snow, hail, and everything. And water and gas is only water vapor. So you can heat water, you can like when you're converting, you can see this evaporation, condensation. It's all basic concepts which we already saw in the earlier part. Okay, now we're going to see how is cloud being formed. Okay, so we're going to talk about cloud formation. Any idea how cloud is being formed?
Ma'am, when water is evaporated.
What is evaporating? Okay, you can be creative. Whatever comes to your mind, you can just tell. How do you think cloud is being formed? Sritej says it's when water is evaporated.
Teacher, first it
Yes.
starts from the sun, teacher. As the sun is heating the river water and ponds water get evaporated, and it when it goes to sky it forms like a gas type, and after that when it combines, a cloud is formed. A piece of cloud, when again and again it gets evaporated, it forms a black cloud. After that we can see the rain.
Okay. Who else?
Ma'am, when the vapor crosses the atmosphere.
Okay. And vapor crosses the atmosphere, cloud is being formed. What are the other ways you think cloud is being formed? That's it. No other way cloud is being formed.
Ma'am, with the gases.
With
Teacher,
this
due
gas.
to
Hmm.
teacher, due to burning of iron and other materials, teacher.
Iron and other materials. Okay.
Teacher, from factory it comes, no teacher, gases.
Okay, but that is not the
And
reason.
if in that only the water gets stored, so we can call it as acid rain.
Okay. I'm not
Acid
talking
rain.
about rain, I'm talking about cloud. So that the industries don't play a role in cloud formation and all. So when the temperature of the air increases, it may be because of the heating up, it may be because of global warming, it can be because of any of the reasons, the atmosphere is getting heated. So you know that heat expands any state of matter, be it air, water, or solid. Anything when it's heated, it expands. So first step, the temperature of the air increases. Second step, due to this, it expands. Okay, expands in the sense if the air particles are like this, because of the continuous heating that is being happening, the air particles will start expanding. They'll move far away from each other. Okay. So it expands where the air particles move far away from each other. So this will make the air becomes light because they are not concentrated like this. They're all far, far away like this. Okay, so it becomes very light. The air gets lighter and lighter as it rises to the atmosphere. So air rises once it expands because of its light weight. Okay, so as the air rises, it takes all the water vapor with it. Okay, the water vapor and everything in the atmosphere. So along with water vapor. Okay, so once it rises, so now it has rised up, so it has all risen up, and the heat is not there anymore. This is the heat, for example. Okay, so it's not there anymore, so it is hot in the lower region. So when it expands, it becomes cool, right? The air above the atmosphere is more cooler. So once it gets cooled down, what will happen? The water vapor will start condensing. So it condenses, so there might be so much of dust particles and everything in the atmosphere, right? So when it condenses on all the dust particles that is present in the atmosphere. Okay, so I'm just giving you an example. Look carefully. You're taking vessel. Okay, and in this vessel you're going to heat the vessel up. Okay, and all the water is there, all water is there in the vessel. So once you close the lid and you remove the lid later, what will be there on top of the lid?
Tiny water drop.
Tiny water droplets. This is because of the process of
Evaporation.
Evaporation.
Evaporation. So listen, look over here very carefully. So here, if you don't close the lid, will you be able to see the water droplets?
No, ma'am.
No. So you need a surface for the droplets to condense on. So if there is no surface, then all the water particles will just fly away, okay, to the atmosphere. Only if there is a surface, it will condense and form tiny droplets. So in the atmosphere, you know that it is a vast area where there is nothing to stop it. So how is it condensing? It's condensing on the dust particles. So dust is solid, right? Dust is tiny particles, which is solid particles. So this dust particles, which is there in the atmosphere, on top of the dust particle only, these air particles, which is along with the water vapor, will condense on. Okay, so please mute the. Okay, so water vapor condenses on dust particle. That is being present in the atmosphere, and this will lead to formation of tiny millions of droplets. So forms millions of tiny droplets. So tiny ice like crystals will be formed if it is very cold in the atmosphere. Okay, so if too cold, these will become ice crystals. Okay, so this cluster of millions of tiny droplets that is floating in the air is what we call this as cloud. So cloud is nothing but it is a cluster of tiny water droplets. Am I clear of how the cloud is being formed? Anybody has doubt, please tell me. Anybody?
No, ma'am. Ma'am, the water droplets will join up with the dust particles.
Yes. That is why you cannot directly drink the rainwater. You have to boil it to clean the dust particle. Risk thana bro. Yeah. No. Did I give you this question? Draw the water cycle. Have I given it to you all?
No, ma'am.
Okay. So this will be a homework question. You can make note of it. Please make it quick because I have next class. If there's any doubt, please ask me. Write it clearly and this whole thing, everything. So write it clearly, and once you're done, you can leave the class.
Teacher, can I leave the class?
Are you done writing?
Teacher, actually I can copy from website. I'm not feeling well.
Okay, okay, fine. Take care.
Ma'am, why can we see clear droplets in the rain?
We see clear droplets because it is not like dirty. It is there are tiny microbial particles, okay, which you cannot be seen in your eyes. So the water is clear only because it passes through. Okay, I'm sorry. See, for example, you have dirty water here. Okay, this dirty water that is there in the cloud passes through the stratosphere, the atmosphere, then the air that is over here. There are so many layers it passes through. So in that layer itself, half of the dust particle will fly away. So it gets clearly filtered. Okay, so there will be tiny microbial particles which you have to clean. That is why the rainwater is very clean because it goes through many layers. Please make note of it, and once you're done, you can leave. I'll be back. Guys, can you please make it quick?
Ma'am, I'm done.
You can do it down, Nida.
Thank you, ma'am. Ma'am, this is Adrit. I'm done.
And leave that.
Ma'am, this is Divya completed.
Okay, done.
Ma'am, this is Sridhar. I'm done.
Okay, done. Ashwath, which line are you in?
Ma'am, I will write a homework bit and I will leave.
Okay, homework
I-
I'll upload in the group. You can note it down.
Ma'am, I should write cloud formation. I
Cloud
will write.
formation. It's a lot. I have next class. Can you just take a picture of it? Can you take a picture, Ashwath?
Ma'am, it is showing you can take a screenshot due to security.